Okay, in this video we are doing Calc Problem Set 81. The problems and a playlist are in the description below, and let's see what we got. Write a definite integral equivalent to, I think this is the first time this has shown up in a problem set. The limit as n approaches infinity, the sum from k equals 1 to n, the quantity 3 plus 5k over n times 5 over n. Okay, so we want to take this limit and turn it into a definite integral. Here's how I always do this. First, I make sure that I'm very clear on what this limit is. So this limit should be a bunch of rectangles, but you're adding up an infinite number of them. So your rectangles are going to have delta x as the base, and they're going to have f of something as the height. So you do f of something times delta x. Then you're going to go from the first rectangle, so k equals 1, up to the nth rectangle. That's like for your picture when you have a finite number. But then you let n go to infinity so that you get an infinite number. Once you've kind of boiled it down to that, now it comes down to looking for things. The first thing you usually want to look for is delta x. So delta x should just be kind of like a multiplier that should have n in the denominator, basically. So I'm going to say that 5 over n is delta x. This is like a really good skill to have, to turn this limit into a definite integral. I have a lot of videos on that. You should definitely check them out. They're in the notes a lot. A lot of examples. Now I need to identify x sub k, because knowing x sub k will tell me what the function is as well. X sub k is going to be like the thing that's kind of happening with delta x. So delta x is 5 over n. I look at this thing and I'm like, oh, it's 3 plus 5k over n. That could definitely be x sub k. I should point out, these answers are not unique. There are multiple interpretations of this particular limit that will give you a particular definite integral. All of those integrals will have the same numerical value, so we're just getting one answer here. A totally valid other option would be to say that x sub k is just 5k over n, but I didn't do that here. Based on this, I now want to find x0, which is where you're starting your integral. It's the lower bound. So you plug in 0 for k and you just get 3. I also want to find x sub n, where I'm plugging in n for k, so I get 3 plus 5, which is 8. So I'm going to have bounds of 3 to 8. And now I need to know what the function is. Well, if x sub k is 3 plus 5k over n, what did I plug that into to get this thing? It must have just been f of x is equal to x. This is a boring function, and I probably should have chosen something different to make it a lot clearer what's happening. But again, check out the other videos to see what's really going on if you're a little confused by this. This is kind of confusing when you first start out. So now I want to just write my integral. So it's going to be the integral from 3 to 8 of x dx. So this also could have been the integral from 0 to 5 of the quantity 3 plus x dx. That would have been totally acceptable, but it's not what I did, and I didn't realize that until I started recording. So here goes. Next problem. Given x cubed y minus xy squared minus 6 equals y squared x squared, write the equation of the line tangent to y equals f of x at negative 2, 3. All right, so we need the slope. That's clearly going to be like the bulk of the work here. We're going to find the derivative with respect to x of both sides of this thing. That's going to be 3 different product rules, and to remember the derivative of negative 6 is 0. So here goes. We're going to have first, derivative of the second is dy dx, plus second, which is y, times 3x squared. That's our first product rule. Now for the second one, I'm going to say that the first function is negative x, and the second function is y squared. I do that all the time when you have like minus a product. Take that negative sign and just put it as a part of the first function. You will make far fewer mistakes. So we're going to go first, negative x, derivative of the second, 2y dy dx, plus second, which is y, derivative of the first, y squared. Derivative of the first is negative 1. So that gets you past that negative sign without any issue. Derivative of negative 6 is 0. So yeah, derivative of negative 6 is 0. Now we got to do the other side. It's just a product rule. So first, derivative of the second is 2x. Second is x squared, derivative of the first is 2y dy dx. Now I'm going to substitute in this point, negative 2, 3. So when I do that, I don't know, I'm just going to plug in and you can see the results. We get negative 8 dy dx plus 36 plus 12 dy dx minus 9 equals negative 36 plus 24 dy dx. That's every x became negative 2, every y became a 3, and then I tried to do the arithmetic correctly. So I think the easiest thing on this problem is to move all the dy dx's to the right, actually, because there's 24 of them on the right-hand side, and there's only 4 of them on the left-hand side, so I'm going to get 20 dy dx's, And then I'm going to therefore move the negative 36 over. So I'll have 36 plus 36 is 72, minus 9 is 63. So we know dy dx is 63 over 20. Then we have to write our tangent line. Just use point slope form, and you will get y minus 3 equals 63 over 20, quantity x plus 2. And there you go. All right, next problem. All right, we're doing definite integrals from graphs, I guess. We want to use the graph of f of x to evaluate the definite integrals. All right, negative 8 to 4 f of x dx. So we got to find some areas. This is half of a 2 by 2, so it's half of a square, so it has an area of 2. This next part is a triangle with a base of 4 and a height of negative 4. So 1/2 base times height is negative 8 in that case. And then we have 2 by 2 is 4, but only half of it, so another 2. This next part of the region, because I have to go all the way to 4, I'm going to split this into a rectangle and a semicircle. So that was a 2 by 4, which is 8. And then up here we have half of a circle that has a radius of 2. So circle with radius 2, area is 4 pi, half of that is 2 pi. So what I want to do for the integral from negative 8 to 4 is I'm going to do, so the negative 8 and the positive 8 cancel. The two little triangles give us 4 total, and then the 2 pi is still there. So 4 plus 2 pi. That's my logic. Now, interestingly, the next question is negative 8 to 8. We already did the work from negative 8 to 4, so we really just have to worry about 4 to 8. But if you look at it, you get one triangle up here and another down there. They're exactly the same size, like geometrically, but their signed areas are opposite, so you contribute nothing there. So the answer to this is exactly the same. It is also 4 plus 2 pi, which is kind of nice because otherwise we'd have to do more work. All right, next up. We want the integral from negative 3 to negative 1 of f of 2x dx. So this is a u substitution problem in my mind. I'm going to say u is 2x, which makes 1/2 du equal dx. So we can sub for dx. Now we have to change the bounds. So forgetting to change the bounds, probably the number one mistake people make here. If x is equal to negative 1, u is going to be negative 2. And if x is equal to negative 3, u is going to be negative 6. So really, we're trying to do 1/2 the integral from negative 6 to negative 2 of f of u du. And now we can just use our graph again. We already found these areas. So this was negative 8. So it's really just 1/2 of negative 8, and 1/2 of negative 8 is negative 4. Good problem. I like that one. All right, the next one is just trying to get you to remember, properties of definite integrals. One of the properties is the sum or difference. The definite integral of a sum or difference is the sum or difference of the definite integrals. Basically, you can just break it up. That's what I'm saying. So I'm going to, first step, rewrite this thing as the integral from 0 to 4 of f of x dx minus the integral from 0 to 4 of 3 dx. So 0 to 4, we did the work before, right? That was 8, that was 2 pi. So that's going to be 8 plus 2 pi. And then for the second one, I'm just going to think of it as a rectangle that has a height of 3 and a base of 4, right? Because you're going from 0 to 4, that's 4. The height is 3, so that's 12. So we're subtracting 12. So our overall answer here will be negative 4 plus 2 pi, or 2 pi minus 4, whichever one you prefer. Doesn't matter. And that's it. That's the little problem set. I hope this was helpful, and good luck.